real life operating conditions, where there's a lot of variations in water demand, the season, um, nominal and actual energy efficiency are always different for centrifugal pumps, while axial piston pump remains constant. As seen in the graph on the right-hand side, the green line is for axial piston pump, and the red line is for the centrifugal pumps. All seawater RO plants operate within a range of variable conditions that affect flow rate and outlet pressure, and thus impact seawater salinity. That is, higher salinity requires more pressure, daily production demand, and third, hourly electricity prices. For the axial piston pumps, the efficiency remains virtually constant across the flow and pressure range. While for the centrifugal pumps, there is an efficiency peak at a specific flow rate. That is the best efficiency point. And any deviation from the BEP decreases the energy efficiency for the centrifugal pumps. Centrifugal pumps operate most efficiently within a small portion of their total potential operating range, preferred operating range, and are generally sized to handle the peak flow requirements at the best efficiency, which typically occurs for just a percentage of total operation time. For this reason, variable frequency drives are commonly installed to adjust the centrifugal pump's operating speed to keep pumps operating as close to the preferred operating range as possible as the system demands change. However, axial piston pump does not suffer this issue since the flow rate is independent of working pressure flow. Therefore, for axial piston pump installed in parallel, just a few numbers of variable frequency drives can be purchased to control the flow variation required. And in a nutshell, axial piston pump maintains consistently high energy efficiency regardless of the flow rate and the outlet pressure. This affects energy consumption and the cost. For example, choosing an axial piston pump over a centrifugal pump for a 5,000 CMD SWRO plant can save you up to 700,000 euros and 8,200 tons of CO2 emissions. That is equivalent to 250 plane trips over a period of 10 years. And that's around the world. Well, with this, I'll hand over to my colleague, Kevin Evald, to talk about our new pump.
Thanks, Amogh. Thanks. Yep. So, I think that was one too many.
Yeah, that was me.
Okay, now I push here. There you go. So, we are introducing this new axial piston pump, which is still a positive displacement pump. You could basically say that we have improved the old axial piston pump with robust technology, where we have changed some of the parts for ceramics to increase the robustness of the pump. The new pump is released in the flow rates from 21 to 38 cubic meters per hour. And we have made 3 different versions, one for seawater RO and one for low pressure industrial wastewater, recycle and reuse, but also one for high pressure industrial water, recycle and reuse. So there's different versions depending on what pressures you want to operate at. They are all prepared for digitalization. That means there's ports for measuring pressures on the inlet ports or the outlet ports. There's also a place where you can mount a vibration sensor and use that for monitoring the operation of the pump. I'll get into the monitoring in a later slide. So the upgraded features is that we are reducing the particle sensitivity of the pump. And this allows us to increase the inspection intervals, basically because the more robust technology is not prone to wear in the same way. So we are reducing this by twice. That also means that this the standard filtration that we require for the pump will be 5 micron nominal, similar to what you see in for centrifugal pumps. This will of course also reduce your service cost, because basically you don't have to service as much as you would previously. The things that we have changed is the valve plates and the port plates. So basically what we have here is the axial piston pumps in an exploded view. The wear surfaces are the ones sliding up against each other, and in this the rotor is in the middle, just on the right side of the valve plate. And the valve plate and the rotor is rotating together with the pistons. And here we have changed the surfaces to ceramics. For the pistons, we have improved the piston body. So when they move in the cylinders, they are not prone to wear in the same way as before because they are hardened. The monitoring for these pumps are available for the APP 21 to 92, including this version of the APP pump with ceramics. The monitoring is allowing us to detect if there's any problems with the product. We are able to identify issues and detect them before they happen. So that is allowing you to do a proactive maintenance on them. It improves your unexpected downtime, and it also helps you reducing your costs for the spare parts, as you will not need as many. When you have the failures, you will typically only exchange the parts that are actually worn and not any damages caused by servicing it too late. The inspections can also be optimized. So where you normally would inspect the pump every second year, you would be able to base your inspections not only on the time from when you did your last service, but also based on the data that you collect from the monitoring device. The benefits of this is that you'll have a higher uptime, as you will not see these unexpected failures. Your reliability is improved, and you're operating the pumps within the limits and to its limits as well in regards to spare parts. And this will of course reduce your costs for maintenance and service.